was Christmas Eve, babe, in the drunk tank. An old man said to me, won't see another one.
Section 3.6 is called Newton's method, and it's named after Sir Isaac Newton. So we all remember that quadratic equations can be solved with a special formula. So for example, if you're trying to solve a formula of the form ax squared plus bx plus c equals 0, you know the way you could solve that. There's different ways you could solve it, but one way that will always work is by using the quadratic formula. X equals negative b plus or minus square root b squared minus 4ac divided by 2a. Right? That'll always work. Well, it turns out there's also formulas that solve cubic equations. Cubic equations are like ax cubed plus bx squared plus cx plus d equals 0. So I'm going to show you the formula. Ready? Boom. Here it is. If you want to solve this equation, you need to use all this. Notice that it's all this plus all this. It's so long you can't even fit it on one line. Not very useful. It's cool that there is a cubic equation, but definitely not all that user-friendly. And it turns out there's also a quartic, which is a fourth degree equation. So if you wanted to solve ax to the fourth plus bx cubed plus cx squared plus dx plus e equals 0, there's actually a formula that solves that too. Ready for it? Here it is. It's so long I can't fit it in here. So there's 4 parts to it. It's for the 4 different roots. So this is the first root right here. Like one of the answers, so to speak, would be this whole top line up here. Do you have any interest in what it actually is? If so, here's what it looks like. The top one looks like, for the first root, you would do negative a over 4 divided by 1/2 times the square root of a squared over 4 minus 2b times blah 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 blah, blah. See, keep going over there. Got to do all this. Keep going. We're not done yet. Got to do all this. Keep going. Not done yet. All this. I'm actually going really fast here, so you can't even see it all. It's absolutely ridiculous, right? You get the idea? No human being on the planet is going to do this to figure out the roots of a quartic equation. So kind of useless, but again, kind of cool too. Once you get above degree 4, above quartic, there is no formula at all. So the way we often find the answers, the roots, the solutions to equations like that is we use graphing technology. We'd graph it and see where it crosses the x-axis. But we can also find approximations to the solutions by using Newton's method. And we can get our approximations to basically be as close to the actual answer as we want. So I'm going to explain first of all the way this works, and then we're going to find a little formula which isn't too complicated, and that'll seem a lot easier. So this is going to be the hard part at the start. So I'm going to start by drawing a function. Let's call this function y equals f of x. And what we're interested in is, what's this point right here? We're going to call it r. And this r stands for the root, or if you want, the solution. Okay, so what we're going to do is we're going to take a guess of how much that is, that r. What's the x value of that point right there? And chances are we're not going to nail it the first time. So let's just say we guess this x value right here. So this is our x1. This is our first guess, or if you want, it's our first approximation. So that's the x value we're guessing. Now let's go straight up from that x value and look at the point right here. This point here obviously has the x value x1. What's the y value? Well, look at the y value. You plug x1 into x right here. So it's f of x1. Okay, now what we're going to do, which is kind of interesting, is we're going to take the tangent that goes through that point right there. There it is, the green line there. I did the best job I could. This is the tangent line to the red function that goes through that blue point right there. And what we're interested in is, what's the equation of this tangent? Okay, so let's think of point slope form, or slope point form. What we do for that is we go y minus y1. Here's our point, right? So y minus y1, well, y1 is f of x1, equals m. M is the slope. how do we get the slope of a tangent line? That should sound familiar. The way you get the slope of a tangent is you take the derivative. So we'd be taking the derivative of f of x. In other words, we'd be having f prime of x, that's our m, and you multiply that by x minus x1. Well, x1 is x1 in this case. Now, if you look, this tangent crosses the x-axis at a point that's even closer to r than what we started with. So this is our x2, and this is our second approximation, or our second guess. And you can see that this second approximation is closer than the first. This is closer than the first to r, if that makes, it's closer to r than the first. So what we're going to do now is we're going to plug that point right there. Well, that point is x2, comma, what's the y value of that point? 0. We're going to plug x2, comma 0 into the equation. Into what equation? This one right there that we just found for the tangent line, right? Because that point is on the tangent line, so that point has to work, has to satisfy that equation. So let's do this. We're going to plug 0 into the y minus f of x1 equals f prime of x. Then where I see x, I'm going to put x squared minus x1. And the last thing we're going to do, stick with me, I know this is really complicated, but I'm trying to show you how Newton's method was figured out, or what it's based on here. The last thing we're going to do is we're going to solve for x2. So to do that, we'll leave this side the same. I mean, it's 0 minus this, so I can just put minus or negative f of x1. I can divide both sides by the derivative of f, and that leaves me with x2 minus x1. And then in order to get x2 by itself, all I have to do is move that x1 over. So I get x1 plus all this, and then I can get rid of that. Sorry, I've kind of done 3 or 4 steps in one go here, but this is what you get when you isolate the x2. Now what you do is exactly the same thing, but you do it again. This x value, x2, you'd go straight up from x2 and find the point on the function. Well, that point right there is x2, comma, f of x2. Then you could draw the tangent line that goes through that point. It looks like this purple one right here. And you can see, by the way, that you get another point. This would be your x3 right there. I can't really fit it in, but that's your x3. Look at how close it is now to this point here. And you would do this whole procedure over again. You'd say, well, I mean, I'd probably stop copying down what I'm doing here, but you'd say the equation of this purple tangent line is y minus f of x2 equals the derivative of f of x2 times x minus x2, and then you could plug x3 of 0 into this equation, work it all through and isolate x3, and you're going to get something very, very similar to this. And you could do this over and over and over as many times as you want. So I know that's hard to follow, but this is hopefully kind of showing you a little bit about how the procedure works. This is probably the part you really are interested, though. This is the actual formula for Newton's method. So it says if x1 is a first approximation, so that's like your first guess, right? This x value right here, to a root of the equation f of x equals 0, then successive approximations are given by, like the next best one, the x2, and then the next one, x3, and the next one, x4, etc., etc., given by this formula right here. X of n plus 1 is equal to x of n minus f of xn over f prime of xn, where n would equal 1, and then 2, and then 3, and onwards as long as you want. And by the way, this is only true if f prime of xn does not equal 0, of course, because then you would have a denominator that's equal to 0. So this looks pretty complicated. It's actually not that bad at all. This is the part you're going to focus on right here. This is just saying to get the next approximation, you take the previous approximation and then subtract f of that previous approximation divided by f prime of that previous approximation. Sound confusing, right? Let's do a couple examples. So it says starting with x1 equals 1, find the third approximation to the root of x cubed plus x minus 1 equals 0. So we want to figure out what the answer is. What value or values could I put into this x here and this x here so that left hand side equals 0? So there's two things you need to be clear of here. First of all, what's f of x? And second, which is going to be very useful, what's f prime of x? So f of x is just the bit that's equal to 0. It's x cubed plus x minus 1. F prime of x is just the derivative of this. Well, this is an easy one to take the derivative of. Power rule, 3 comes down, 3x squared. Power rule, 1 comes down, you just get plus 1. This is a constant, so it equals 0. I don't have to write anything down at all. Okay, so we already know that x1 is 1. Now we want to find x2. How do we do that? Well, the formula in the previous page tells us that to get x2 is we take x1, right? We take the previous one, and then do f1 over f prime of 1. So x2 equals x1 minus f of x1 divided by f prime of x1. Alright, well x1 is 1 minus f of x1. Well, x1's 1, so we're going to plug that into f. So we're putting 1 into here. So we get 1 cubed plus 1 minus 1, all divided by. Now we're going to take x1 again, which is still 1, and we're going to plug it into f prime. So we're putting 1 here. We get 1 squared is 1, times 3 is 3, so we get 3 plus 1. If we simplify that, you get 1 minus 1 cubed is 1, plus 1 is 2, take away 1 is 1, 3 plus 1 is 4, so you get 1 minus 1/4, or 3/4. So that is our x2. Now, what if we want to get x3? Because we want the third approximation. To get x3, you take the previous one, which is x2, and then you subtract f of x2 over f prime of x2. Now, you're getting to the point where you want to start using a calculator, I'm sure, but let's just write a little more here. x2 is 3/4 minus, so now you're doing f of x2. You need to plug 3/4 here and here. Maybe I'll just quickly do it up top. 3/4 cubed is 27 to the 64 plus 3/4 minus 1. If you get common denominators here, you have to multiply by 16, so you get 48 over 64 minus 64 over 64. It gives you 11 over 64. On the bottom, you have to take x2, which is 3/4, and plug it into the bottom. So we would have 3/4 squared, which is 9/16. So we'd have 3 times 9/16 plus 1. 3 times 9/16 is 27/16 plus, well, 1 is 16/16, so you get 43/16. So I guess the next thing you could do is you could go 11/64 divided by this, but that's the same as multiplying by 16 over 43. You can cancel this and this and get 1/4, so you get 11 over 172. And the last thing you have to do is 3/4 minus 11 over 172. Common denominators, you're going to have to multiply this by 43. 43 times 3 is 129, and if you subtract that, you get 118 over 172, which you can put in the lowest terms and get 59 over 86. Or as a decimal, it's approximately 0.6860. This one, of course, is 0.75. So you can see it's close, but I'm promising you here, you're getting closer and closer to the actual answer. Now, is this actually the amount you could plug in here and here and make it equal 0? No, but it's very, very, very close to the actual answer. What would we do if we wanted to get even closer? We'd do x4 equals x3 minus f of x3 over f prime of x3. Like that. Now, I know you were probably getting quite annoyed with me by doing all this red stuff up here. You want to use a calculator. So that's what we're going to do for the other two questions. Use Newton's method to find the fourth root of 13, correct to 4 decimal places. Well, we need to write this in a way that we can use Newton's method. And the way we're going to do that is we're going to define this amount as x. So x equals the fourth root of 13. Well, if x is equal to the fourth root of 13, then what we could do to both sides is raise it to the fourth power, and you get x to the fourth equals 13. And then remember, to use Newton's method, we want it to be equal to 0, so just move the 13 over. X to the fourth minus 13 equals 0. So again, what we want to start with is our f of x and our f prime of x. We've got our f of x. It's x to the fourth minus 13. We can get our f prime of x very easily. Just take the derivative of this, which equals 4x cubed. Now, it doesn't tell us what to start with here. We need to come up with an x1. So we need to come up with an estimate, a guess of this. Don't plug this in your calculator and call that your first guess. No, you're not allowed to do that. I know it's kind of artificial and say, well, if I have a calculator do the rest of the question, why don't I use my calculator to do this? I know, but you just can't. You're not allowed. So we need to take a guess here. Well, what's it going to be between? If I raise 1 to the fourth power, I get 1. If I raise 2 to the fourth power, I get 16. Whoa, we already know it's between 1 and 2, and it looks like it's going to be closer to 2. So if you wanted to, you could just put 2 as your answer. Or maybe you want to put 1.7, because that might cut down a step or two. Or 1.8, I don't know. Take a guess like that. But I'm just going to go with 2. So that's my x1. Now I have to get my x2. Remember, x2 equals x1 minus f of x1 divided by f prime of x1. So it equals 2 minus, well, I can actually do this without a calculator. If I put 2 into x1, I get 2 to the fourth, which is 16, minus 13 is 3. And if I put 2 into f prime, I get 2 cubed, which is 8, times 4 is 32. So I have 2 minus 3 32s, which is, this is 64 32s minus 1 is 61 32s, which is approximately equal to 1.906250. So we're going to do this for a lot of decimal places. I'm going to put 6 here. Well, I've already done it. 6 decimal places. And I'm actually going to start using my calculator now. I'm going to do that 61 over 32. Here we go. 61 divided by 32. And we get the amount I already said. Okay, so now what we're going to do is we need to find what x3 is. So x3 will equal x2 minus f of x2 divided by f prime of x2. Let's put the calculator right here. Now this answer button, you see mine's in orange here, or yellow, whatever. Now it's kind of a drag because I have to hit second every time. But when you're doing these questions, you really want a calculator that has an answer button, and it'd be even better if it's a calculator whose answer button you don't have to hit a second button to access. Having these bracket buttons are also very, very useful here. Okay, so what I do is I take x2, well, there's x2 right there. Why don't I just start by hitting answer? That answer right there is exactly x2. So I've done the x2. Minus, so minus. Now I'm going to put this in brackets. I'm going to put my numerator in brackets. I'm going to do f of x2. Remember, f of x is x to the fourth minus 13. X is where I put the answer. So I'm going to put answer to the fourth power. So answer to the fourth power, and then I have to subtract 13, and this will be my numerator. So I'll close the bracket and I'll divide that by the denominator. The denominator is f prime of x2. So I'm going to take the answer, remember x2 is the answer, I'm going to put it in here. So I'm going to put a bracket again for the denominator. I'm going to put 4 times the answer cubed. And you don't have to, but I'll close the bracket, hit enter or equals, and I get 1.898872145. It should be somewhat similar to what we had as our previous answer, and it is. Before we had 1.906250, now we have 1.89887 whatever. So this is looking good. So I'm going to write this answer down. This is my x2 answer, and I have as my x3 answer 1.898872. I'm going to go to 6 decimal places. Oh, although it actually says I only have to go to 4. But still, you want to put at least 5 at the least. You'll know why in a second. Because you might be saying to yourself, well, why don't I stop here? And the reason you don't stop is because our first 4 decimal places don't match each other yet. So you got to keep going. Now we're going to do x to the 4. How you do x4? You do x to the 3 minus f of x3 divided by f prime of x3. You don't have to write this and this and this. You don't have to write this every time. I'm just doing this to help you see how I'm getting my answer. So this amount right here, which is already in my calculator, don't clear your calculator. Don't Don't get rid of this answer. We want this. This will make it so much easier for us. That's already in there. So I'm going to start with that. That's my x3. That's my answer. So if you want, in this calculator anyway, I don't even have to hit answer. I can just hit minus. And if I hit minus, it knows I mean answer minus. I'll show you. I'll hit minus. Look at answer minus. So I've already done that. Now I'm going to do the numerator. So bracket. I want f of x3. So remember f of x was x to the fourth. So I want answer to the fourth power. I want to take away 13 and close that bracket. Then I want to divide that, open up the bracket for the denominator. I want to do f prime of the answer. So I'm putting the answer into 4 times answer cubed. So I get my answer and I cube it. Close the bracket if you want. Hit enter. Look, it's getting very close to the previous answer. This is good. So let me write this answer down. I get x to the fourth equals 1.8988829. And you can see that the first four decimal places here match the first four decimal places done here. So we're done. As soon as you get the same thing for the amount of decimal places you're interested in, we've got our answer. In this case, my answer would be x to the fourth equals 1.8988, 4 decimal places. We are finished. Whew, bit crazy, eh? It's annoying a little bit, I know. Okay, find the coordinates of the point of intersection of these two curves. Correct to 6 decimal places. So sadly, the first thing you're going to have to do is you're going to have to give a very simple sketch. Otherwise, we're going to have no clue where it could possibly be. So x to the fifth. Let's graph that really fast. If I put a 0 in here, you get 0, 0. If I put a 1 in here, you get 1, 1. If I put a 2 in here, you get 232. Whoa, it's way up there. If we put negative 1 in here, you get negative 1 to the fifth, which is negative 1. If you put negative 2 in here, you get negative 32. So this graph goes something like this. Now this graph, I'll also do in blue. This is just a parabola that has its vertex at 0, 1, and it opens upwards. So it goes something like this. So this is the point we want right here. So we want to know where they cross each other. We want to know, in other words, if we take the x to the fifth power and equate it to x squared plus 1, we want to know when this will be true. So in order to be able to use Newton's method, you want it to equal 0. So let's move this stuff over to the left. X to the fifth minus x squared minus 1 equals 0. Great. We have our f of x. It's x to the fifth minus x squared minus 1. And we have our f prime of x. Derivative of this is 5x to the fourth minus 2x. Okay, we need an x1. So what would be a good guess here? Well, remember this point right here was 1, 1. And if you put 1 in here, you get 1 squared is 1 plus 1 is 2. So this one goes through 1, 2. This point probably around right there is 1, 2. If you put 2 in here, you get 5. So somewhere around here, you get 2, 5. But 232 is way up here. So you can see that it's kind of closer to 1. It's a lot closer to 1 than it is to 2. By the time you get to 2, they're really far apart. So it must be very close to 1. I don't know. Let's call it 1.1. Okay, so now we have to find x2. How do we do that? I'm only going to write this one time this time. You're going to take x1. Well, this time I'm going to do it this way. You're going to take x1, which is 1.1, and you're going to subtract f of 1.1 divided by f prime of 1.1. Okay, so let's go to the calculator. Now, the first thing I want to do is get 1.1 into my calculator. So I can do that. I can just put 1.1 and just hit enter, and there you go, I got 1.1. Now I have it as my answer. So the next thing I have to do is I have to take that amount and subtract this. So I can just hit minus, at least on this calculator. Most of them should do that. It says answer minus f of 1.1. So I want to put 1.1 in here. So that means I have to do open bracket for the numerator, 1.1 to the fifth power minus 1.1 squared, there's a squared button here, so that's nice, minus 1. That's the numerator. Close the bracket. Divided by, open the bracket, we've got to do the denominator, which is f prime of 1.1. I got to put 1.1 in here now. So I'm going to go 5 times 1.1 to the fourth power minus 2 times 1.1, and I can close the bracket. And if I do that, I get 1.217 blah 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 blah. So let's write that down. This is x2. So I should do it to 6 decimal places, since that's what it's asked me to do here. 1.217076. Now I do the same thing again, but this time I'm not putting 1.1 here, here, and here. I'm putting this. This is my new answer. Okay, I don't often do this, but I'm not actually going to show you the rest of the steps. I think that would be a little bit much. I don't think there's much value in you seeing me punch things into a calculator, but I really strongly recommend you try this. The next thing you should get for x3 is 1.194913. So obviously we got a little ways to go. We don't have even the first number after the decimal the same. x4 you would get 1.193861. Okay, we got 2 the same. We want 6 the same. Little ways to go. x5 is 1.193859. Oh, it's looking good now. We're all the way to 4 the same. So let's hope for x6 that we get 6 the same. And it turns out with x6 you get 1.193859. There is 6 the same. So we know that this is our answer. It took our 6th approximation to get there. And this is not exactly the x value of where they cross, but it's pretty darn close. Now, by the way, if they want the point of intersection, that means they want an x value and a y value. So our point is 1.193859, and how are we going to get the y value? You're going to plug it into either here or here. It doesn't matter which one. I would probably plug it into the x to the 5th, since it's just one thing to do. And if you do that, you're going to get 2.425298, and that would actually be your answer, because that is a point, and that's exactly what they asked for. Okay, sorry this is so long, sorry this is so finicky and annoying, but that's Newton's method.
The boys of the NYPD chorus are singing Go Away Bride, and the bells are ringing out for Christmas Day.